In this talk, I shall try to explain why I think art is the appropriate word. I will discuss what it means for something to be an art in contrast to being a science. I will try to examine whether arts are good things or bad things, and I will try to show that a proper viewpoint of the subject will help us all to improve the quality of what we are now doing. Hello, my name is Eric Normand, and this is my podcast. Welcome. Today I am reading from the 1974 ACM Turing Award Lecture. The award was given to Don Knuth. He's something of a legend in computer science, and I'm going to read from his biography. I've been waiting to do this one for a while. I hear all these little stories about him, but I had never read this lecture. And interestingly, from his biography, he was given this award in 1974. He was born in 1938, which makes him 36 years old when he got the award. It's very young. It's younger than I am now. So to me that seems like, wow, that's pretty accomplished by this age. But also we're lucky that he has a lot of lectures and interviews and even like podcast appearances that are still happening. So you can still hear from him, like in the voice, and you can see him and everything, which is really cool. I mean, if you want to learn more about him, that's often a really good way to do it. You get a much richer feel for the person that way. Okay, so let's go into his biography. I like to read what, they tell you what he was awarded it for. So 3 things: analysis of algorithms and the design of programming languages, and the art of computer programming. So these are all for contributions in general, but 3 things: analysis of algorithms, design of programming languages, and art of computer programming. And of course, he is well known for having written the book, the large multi-volume book called The Art of Computer Programming. He also has what is sometimes referred to as the biggest yak shave in history, which is I'll get to that. I'll read from here. Okay. I just have a few points from the biography that I want to read. All right. This is about the book that he was writing. The word got around that he knew a lot about compilers, and in 1962, in his second year at Caltech, Addison Wesley asked him to write a book on compilers. He sketched 12 chapters and signed a contract. After receiving his PhD in 1963, Knuth began working on a chapter on sorting, a topic related to some compilers. So, just to stop here, the book started out to be a book about compilers, not computer science in general, just compilers. He read many technical articles and noticed the spotty and sometimes unreliable nature of the literature in the then new field of computer science. He saw the need for someone to write a book which organized and reliably presented what was then known about the field. Knuth was a good writer and had an instinct for trying to organize things, so he decided to tackle it. He used a quantitative rather than qualitative approach and emphasized aesthetics, the creation of programs that are beautiful. The book grew longer as he wrote it, reaching 3,000 handwritten pages, the equivalent of 2,000 printed pages, by the time he finished the first draft of the 12 chapters in June 1965. Okay. There's a little bit more history about how it was published into different volumes and stuff. Okay. Some more about the book. The Art of Computer Programming emphasized a mathematical approach for comparing algorithms to find out how good a method is. Arguably, the book's established analysis of algorithms as a computer science topic in its own right. So another thing I want to emphasize, like, this is very, when we talk about like order n algorithms, order n squared algorithms, that's all what he's talking about in analysis of algorithms. It's like very commonplace today. It's in all the big companies' interviews where they want you to figure out how to turn a quadratic algorithm into an n log n algorithm, something like that. And then the other thing is this duality between using a quantitative method, quantitative approach, and emphasizing aesthetics. So not using a qualitative approach, but trying to actually pin things down with numbers, and then also emphasizing aesthetics, which seem to contradict. But that's what he goes into in the lecture. Okay. So also the book served as a focal point for developing curricula and as an organizing influence on computer science. Okay, so this is a theme that comes up a lot in Knuth's work, is just organizing. He's like monastically taking all the stuff that we know and boiling it down into reference, these big books. And it takes a certain kind of mind to do that. And he's really good at it. Okay, so now we're talking about tech, which is what I was talking about, the biggest yak shave in history. Knuth is well known for his perfectionism and offers to pay $2.56 for each error found in his books. Finding one confers prestige on the discoverer, many of whom frame and display the hand-signed check rather than cashing it. Of course you'd want to keep the check. It's only $2.50. Okay. So he revised the first 3 volumes, and then he was deeply disappointed when, in 1973, he saw the typesetting from Addison Wesley for the second edition of Volume 2. By then, the publishing industry had replaced traditional mechanical typesetting technology with computerized typesetting that did not reproduce the high quality of the original printings of Volumes 1 through 3. In 1977, Knuth began developing a new typesetting system to enable high-quality computerized typesetting. He had 2 goals for his system. 1, achieving the finest quality printed documents. 2, creating a system that would be archival in the sense that it was independent of changes in printing technology to the maximum extent possible. Okay, so imagine this. You are something like 10 years in, maybe not 10 years, 5 years in, 16 years in to writing your magnum opus, and you realize that the typesetting is not up to your standards. So do you spend another decade? Let's read this. Knuth thought his typesetting work would take a year or 2, but it was not until 1990 that he announced that he would make no further changes to his systems except to correct serious bugs. Okay, this is a serious yak shave because tech is a system that is widely used all over the world for writing technical papers, for publishing books, etc. And he was doing this in order to typeset his own book. I mean, spent years and years developing this, probably alongside each other, let's be honest. But he kept developing it because he still had things he wanted it to do that he needed for his book. So that's biggest yak shave in history. Okay, I'll just conclude with this. He credits much of the work of his... He credits much of the success of his work to combining theory with practice. Knuth is the rare theoretician who writes many lines of code every day. Programming is an art he practices often. Okay. When I was younger, I thought it was sad that he was dedicating his life. You know, he retired early so that he could work on the book more. It just seemed very final to dedicate your life to something like that. But he's having fun, and he's still programming stuff on the side. He still publishes lots of research papers. So I think that maybe it's not so sad to have a project like that that's having such a big influence on the industry. Now that I'm older, it would be really nice to have a project where, like, okay, I know what I'm doing for the rest of my life. Okay, let's get into the lecture itself. Just as a reminder, I'm not going to read the whole thing. I'm just going to excerpt some sections, and I will give my own comments. A lot of them will just be personal opinions and commentary. It's not super technical. Sometimes it gets technical, and my commentary is more like I did some research to figure out what he was talking about or what the author was talking about. In this one, it is not so technical, so it's going to be a lot more my personal reflections on it. There's a citation at the beginning, which by that they mean a little introduction to the person and to why they got the award. And this one was written by Bernard Galler, who was chairman of the committee. So I'm just going to read one little sentence from it. The vocabulary, the examples, the algorithms, and the insight that Don Knuth has provided in his excellent collection of books and papers have begun to find their way into a great many discussions in almost every area of the field. Okay, so that just shows his influence and why he's the one who got the award that year. Okay. And I think that I have a degree in computer science, and they were just throwing out his ideas left and right. They were just in the textbook, but a lot of them just came right out of him. So, doesn't get as much credit as he deserves. Okay, now I'm going to start. This is called Computer Programming as an Art by Don Knuth. When Communications of the ACM began publication in 1959, the members of ACM's editorial board made the following remark as they described the purposes of ACM's periodicals. If computer programming is to become an important part of computer research and development, a transition of programming from an art to a disciplined science must be effected. Such a goal has been a continually recurring theme during the ensuing years. For example, we read in 1970 of the first steps toward transforming the art of programming into a science. Meanwhile, we have actually succeeded in making our discipline a science, and in a remarkably simple way, merely by deciding to call it computer science. That's a funny joke. Implicit in these remarks is the notion that there is something undesirable about an area of humanity that is classified as an art. It has to be a science before it has any real stature. On the other hand, I have been working for more than 12 years on a series of books called The Art of Computer Programming. People frequently ask me why I picked such a title, and in fact some people apparently don't believe that I really did so, since I've seen at least one bibliographic reference to some books called The Act of Computer Programming. I made another joke. Okay, yeah, that's good, get the crowd warmed up with these little jokes. Okay, and now I read this part already. In this talk, I shall try to explain why I think art is the appropriate word. I will discuss what it means for something to be an art in contrast to being a science. I will try to examine whether arts are good things or bad things, and I will try to show that a proper viewpoint of the subject will help us all to improve the quality of what we are now doing. Okay, so like I said, this isn't going to be very technical. He's talking about the meaning of the word art and science and comparing them and how they've changed over time. Okay. If we go back to Latin roots, we find ars, artis, meaning skill. It is perhaps significant that the corresponding Greek word was techne, the root of both technology and technique. Nowadays, when someone speaks of art, you probably think first of fine arts, such as painting and sculpture. But before the 20th century, the word was generally used in quite a different sense. This older meaning of art still survives in many idioms, especially when we are contrasting art with science. So, the thing I want to mention in this little section is he's really diving deep into these words. Earlier, he says that art must be one of the most interesting words in the English language because he spent days researching this. And I really find it, when I do something like that, when I deep dive on a word, like what does it mean? Where does it come from? I know a lot of words, like we all do, but have I really figured out what it means and where it comes from? When I do that, because I sometimes will do that, I feel like it's like refactoring my understanding, refactoring my mind, and I've got like new ways of thinking. So that's what he's doing here, and he's trying to impart that. And anyway, in medieval times, the first universities were established to teach the 7 so-called liberal arts, namely grammar, rhetoric, logic, arithmetic, geometry, music, and astronomy. Note that this is quite different from the curriculum of today's liberal arts colleges, and that at least 3 of the original 7 liberal arts are important components of computer science. What I think he's referring to is logic, arithmetic, and geometry. Maybe rhetoric instead of geometry. Geometry is probably more like it. Okay. At that time, an art meant something devised by man's intellect, as opposed to activities derived from nature or instinct. Liberal arts were liberated or free, in contrast to manual arts, such as plowing. During the Middle Ages, the word art by itself usually meant logic, which usually meant the study of syllogisms. Okay, so this is interesting that there were actually an enumerated list of the liberal arts that was what you learned at a liberal arts university. we today think that, I think it's kind of quaint, but they probably understood these better than we do today, even having taken a class in, grammar. Okay, let's continue on. But well, before we continue, I just want to re-emphasize, an art meant something devised by man's intellect. Of course, he's using man to mean human, right? At that time, an art meant something devised by human intellect. Okay. Right, next. The word science seems to have been used for many years in about the same sense as art. For example, people spoke also of the seven liberal sciences, which were the same as the 7 liberal arts. Okay, so they're kind of equivalent. As civilization and learning developed, the words took on more and more independent meanings, science being used to stand for knowledge and art for the application of knowledge. Thus, the science of astronomy was the basis for the art of navigation. The situation was almost exactly like the way in which we now distinguish science and engineering. Okay, so the science is knowledge, and the art is the application, right? Just like we use engineering for the application of science, even though it's not exactly what it means. Okay, you can have engineering without science. As I was looking up these things about the meanings of art, I found that authors have been calling for a transition from art to science for at least 2 centuries. According to most dictionaries, science means knowledge that has been logically arranged and systematized in the form of general laws. The advantage of science is that it saves us from the need to think things through in each individual case. We can turn our thoughts to higher level concepts. As John Ruskin wrote in 1853, quote, "The work of science is to substitute facts for appearances and demonstrations for impressions." Whew. I don't know if I would pull out a book from 1853 to understand words for a lecture I was giving, but maybe I should, Maybe that's why he's getting the Turing Award and I'm never going to get it. Okay. It seems to me that if the authors I studied were writing today, they would agree with the following characterization. Science is knowledge which we understand so well that we can teach it to a computer. And if we don't fully understand something, it is an art to deal with it, since the notion of an algorithm or a computer program provides us with an extremely useful test for the depth of our knowledge about any given subject. The process of going from an art to a science means that we learn how to automate something. Okay, so if you can write a computer program to do a thing, then you understand it in a scientific sense. It's mechanical. Okay, it's something you can automate. But if you don't understand it, it's still an art. You can do it, right? But you don't understand what you're doing. Not in the way that you would understand a science. Artificial intelligence has been making significant progress, yet there is a huge gap between what computers can do in the foreseeable future and what ordinary people can do. Nearly everything we do is still an art. Still true, even though we have GPT-3. Somehow it's not quite there. From this standpoint, it is certainly desirable to make computer programming a science, and we have indeed come a long way in the 15 years since the publication of the remarks I quoted at the beginning of this talk. 15 years ago, computer programming was so badly understood that hardly anyone even thought about proving programs correct. We just fiddled with a program until we knew it worked. At that time, we didn't even know how to express the concept that a program was correct in any rigorous way. When we write programs today, we know that we could in principle construct formal proofs of their correctness if we really wanted to. Now that we understand how such proofs are formulated, this scientific basis is resulting in programs that are significantly more reliable than those we wrote in former days when intuition was the only basis of correctness. So, he's saying that we've done quite a lot to make it scientific in the sense of being able to formalize and automate something. The field of automatic programming is one of the major areas of artificial intelligence research today. Their aim is to create machines that write programs better than we can, given only the problem specification. Personally, I don't think such a goal will ever be completely attained, but I do think that their research is extremely important because everything we learn about programming helps us to improve our own artistry. In this sense, we should continually be striving to transform every art into a science. In the process, we advance the art. Okay. So he's talking about art and science. That science is the knowledge and art is the practice. It's the application. And so the more we can turn into knowledge, say you could write it down and maybe write a computer program if it's really formalized enough, the better, because that actually pushes what we can do in practice. Our applications grow, right? The application of programming grows as our formalized part grows. So they work in tandem. Our discussion indicates that computer programming is by now both a science and an art, and that the two aspects nicely complement each other. Apparently, most authors who examine such a question come to this same conclusion, whatever their subject is. That's really interesting. And he gives some examples. Actually, when I chose the title of my books, I wasn't thinking primarily of art in this sense. I was thinking more of its current connotations. Probably the most interesting book which turned up in my search was a fairly recent work by Robert E. Mueller called The Science of Art. He observes, quote, "It was once thought that the imaginative outlook of the artist was death for the scientist, and the logic of science seemed to spell doom to all possible artistic flights of fancy." Unquote. He goes on to explore the advantages which actually do result from a synthesis of science and art. So interesting, right? That they do work together. If you have both, you have the creative, artistic side, and you have the logical, scientific side. When I speak about computer programming as an art, I am thinking primarily of it as an art form, in an aesthetic sense. The chief goal of my work as educator and author is to help people learn how to write beautiful programs. My feeling is that when we prepare a program, it can be like composing poetry or music. As Andrei Urshov has said, programming can give us both intellectual and emotional satisfaction. because it is a real achievement to master complexity and to establish a system of consistent rules. So this, just a personal reflection here. I remember when I was in high school, maybe early college, I read an essay where someone was talking about why they liked programming. And they had also talked to other people about it, and there was some agreement about it. And what they said was that people like programming because it gives them control over a complicated, complex piece of equipment. So you type in the program and it does the thing, and if it doesn't do what you expect, it's your fault because you typed it in wrong, you got a syntax error or something. And but when you get it right, you get credit for it, right? So there's something about that they found appealing. Now, when I read that, it just did not ring true with me. That is not why I like programming. And so I thought about it for a while. And it's not the control. I don't want to have control over a machine. That's not satisfying to me. What I like is what he was saying. This real achievement to master the complexity, not the complexity of the machine, but the complexity of ideas, and to establish a system of consistent rules. This idea that you can actually explore ideas, that is what really appeals to me. And it probably shows if you've listened to this podcast before that's kind of what I'm into. And I feel kind of a camaraderie with Don Knuth because I feel like he's expressing my feeling of it. That I'm not just like a plumber, who like feels good about having his pipes all in order and everything. No, I want consistency of ideas, that the computer can show us where our ideas are inconsistent and help us understand them better, because they have to run. If they don't run, they don't do what you expect, maybe your ideas aren't fully clarified. So that's my personal reflection. That's what I thought of when I read that. Furthermore, when we read other people's programs, we can recognize some of them as genuine works of art. I can still remember the great thrill it was for me to read the listing of Stan Poley's SOAP 2 assembly program in 1958. So this is like not 20 years later. When was this again? 1974? Yeah, so 16 years later. You probably think I'm crazy, and styles have certainly changed greatly since then. But at the time, it meant a great deal to me to see how elegant a system program could be, especially by comparison with the heavy-handed coding I found in other listings I had been studying at the time. The possibility of writing beautiful programs, even in assembly language, is what got me hooked on programming in the first place. Some programs are elegant, some are exquisite, some are sparkling. My claim is that it is possible to write grand programs, noble programs, truly magnificent ones. Okay, now at this point I feel like he's really on a roll because I highlighted like everything. And so this is going to take a while. I really tried to find stuff to skip. This is the part where he even mentions that this is what he feels the most passionate about. But I want to comment on this section I just read. It's a big regret of mine that most of my friends don't program. And I find it hard. I find it hard to share it with them. If I made a painting or a piece of music, I could be proud and show them, look what I did. And, maybe they don't think it's impressive, but I just want someone to see it. But if I show them the code, they're like, I don't know. That's like reading Klingon. I don't know what that is. So, I think that sucks. That really sucks that you can't share these works of art with non-programmers. And, well, I don't know if there's anything to do about that. I don't know. The idea of style in programming is now coming to the forefront at last, and I hope that most of you have seen the excellent little book on elements of programming style by Kernighan and Plogger. In this connection, it is most important for us all to remember that there is no one best style. Everybody has his own preferences, and it is a mistake to try to force people into an unnatural mold. We often hear the saying, I don't know anything about art, but I know what I like. The important thing is that you really like the style you are using. It should be the best way you prefer to express yourself. Okay, again, I caught this. I mean, it's really weird to say it nowadays. This is 2021. If someone wrote this now, it would be very awkward, but he wrote, everybody has his own preferences. So everybody obviously includes women, but then his, it just sounds weird. So I apologize for that, but just for historical, I don't want to edit what he's writing. And it's hard to do it in the moment. Everybody has their own preferences is how I would say it. Right. So he's saying that he's not trying to say that there is even a possibility of kind of comparing styles, right? There's no better style, worse style. It's a matter of personal preference. Edgar Dijkstra stressed this point in the preface to his short introduction to the art of programming. It is my purpose to transmit the importance of good taste and style in programming, but the specific elements of style presented serve only to illustrate what benefits can be derived from style in general. In this respect, I feel akin to the teacher of composition at a conservatory. They do not teach their pupils how to compose a particular symphony. They must help their pupils to find their own style and must explain to them what is implied by this. Okay. They have to find their own style. That's the key of an art teacher, is to help the student find their own style. Now we must ask ourselves, what is good style and what is bad style? We should not be too rigid about this in judging other people's work. The early 19th century philosopher Jeremy Bentham put it this way: judges of elegance and taste consider themselves as benefactors to the human race, whilst they are really only the interrupters of their pleasure. Okay, hang on a second, because this is from the early 19th century. So we're going to have to go through it again. So I'm going to read it once through, and we're going to go through it a little at a time. Okay, so I'll start the Jeremy Bentham quote again. Judges of elegance and taste consider themselves as benefactors to the human race, whilst they are really only the interrupters of their pleasure. There is no taste which deserves the epithet good unless it be the taste for such employments which, to the pleasure actually produced by them, conjoin some contingent or future utility. There is no taste which deserves to be characterized as bad, unless it be a taste for some occupation which has a mischievous tendency. Okay, so let's go through it one sentence at a time, because I had to myself reading this. Judges of elegance and taste consider themselves as benefactors to the human race, whilst they are really only the interrupters of their pleasure. Okay, so there's critics, there's judges who say, that's no good, that's not good taste, this is better taste. Snooty people, snobs. They think they're doing the world a favor. I'm just paraphrasing. They think they're doing the world a favor, but really, they're only stopping their own pleasure. Okay? There is no taste which deserves the epithet good, unless it be the taste for such employments which, to the pleasure actually produced by them, conjoin some contingent or future utility. There's no taste which deserves the epithet good, unless, so there are some that maybe you could call good, unless it be the taste for such employments which, to the pleasure actually produced by them, conjoin some contingent or future utility. So it's got utility with pleasure conjoined, right? The pleasure that thing, that taste gives you with utility. So it has to be useful. And then there's no taste which deserves to be characterized as bad, unless it be a taste for some occupation which has a mischievous tendency. So he's kind of saying if it's just causing havoc, maybe it's not good taste. Okay, Knuth continues. When we apply our own prejudices to reform someone else's taste, we may be unconsciously denying them some entirely legitimate pleasure. That's why I don't condemn a lot of things programmers do, even though I would never enjoy doing them myself. The important thing is that they are creating something they feel is beautiful. Super important. Taste, style in programming, even skill in programming, a lot of what I'll speak from my experience. As I've gotten better over the years in programming, there are some things I don't do anymore that I learned that I don't like doing because it gets me stuck somewhere or it causes bugs. And I'll see people who are, starting out, they're on their journey, and they're doing those things. Now, should I condemn what they're doing? I've concluded no. They're at a specific point, they're learning. I look at my 2 kids, and they do stuff that I would never do because I know it's no good. But they need to learn, and maybe even the exploration is pleasurable. And so, if it's not causing harm, if it's not going to be a danger, let them do it, right? If they want to, I don't know, I'm just trying to think of something silly that I see them do. Color in a certain way, like with holding 4 crayons at the same time. Okay, do that. That's fine. You're just experimenting with a thing, with the medium. I would never do that because I know what it looks like and I don't like it. Okay. The other thing I want to say about this is I'm just so impressed by the depth of the research. he's quoting Jeremy Bentham. I mean, let me figure out exactly what year this book is from. 1811, although it wasn't translated into English until 1825. So you're given an award in 1974 and you decide, I gotta brush up on my Bentham. It reminds me of like the stuff he's saying here. Like people have known for a long time. Bentham wrote it down eloquently in this book, but people knew it before, right? And I'm just always amazed by how much we have to rediscover in our lives, even though people knew it. Like, I'm not a great reader. I know people who were like, oh yeah, I read Bentham. I know people like that who've read thousands of books, and they would bring them up in conversations. They'd be like, oh yeah, the Bentham said that years ago, 200 years ago now. And I'd be like, oh, well, too bad I didn't read that because I just went through a huge, expensive learning experience that I could have saved all that time. Yeah. So I don't know. I wish I could do this. I wish I had like a store of knowledge from all the philosophers in the past. Because it would be really useful. Living hand to mouth here. Okay. In the passage I just quoted, Bentham does give us some advice about certain principles of aesthetics which are better than others, namely the utility of the result. We have some freedom in setting up our personal standards of beauty, but it is especially nice when the things we regard as beautiful are also regarded by other people as useful. I must confess that I really enjoy writing computer programs, and I especially enjoy writing programs which do the greatest good in some sense. There are many senses in which a program can be good, of course. In the first place, it's especially good to have a program that works correctly. Secondly, it is often good to have a program that won't be hard to change when the time for adaptation arises. Both of these goals are achieved when the program is easily readable and understandable to a person who knows the appropriate language. Okay, I mean, common sense stuff here. It has to work correctly. That's a kind of utility. Being able to adapt it, that's a kind of utility. Being easy to read and understandable, that's another kind of utility. Another important way for a production program to be good is for it to interact gracefully with its users, especially when recovering from human errors in the input data. It's a real art to compose meaningful error messages or to design flexible input formats which are not error-prone. Okay, so there's another kind of utility. Not being error-prone, or at least having good error messages. Another important aspect of program quality is the efficiency with which the computer's resources are actually being used. I am sorry to say that many people nowadays are condemning program efficiency, telling us that it is in bad taste. The reason for this is that we are now experiencing a reaction from the time when efficiency was the only reputable criterion of goodness, and programmers in the past have tended to be so preoccupied with efficiency that they have produced needlessly complicated code. The result of this unnecessary complexity has been that net efficiency has gone down due to difficulties of debugging and maintenance. Okay, I think he's going on a little tangent here. He's talking about efficiency, that efficiency is a utility. It's a source of good taste. But people are condemning it. He's talking about the reason being that there was a time before when computers were so constrained that was like a real mark of skill. And so that's what people focused on. Even getting the program working in the memory, that was, the small memory, maybe making it run faster, use fewer instructions, that kind of stuff was the primary goal of programming. I mean, once it worked in theory. And he's saying that sometimes the efficiency, you focus on efficiency so much that your program gets so complicated that it's actually not efficient anymore. You can't understand how it works. And of course, you don't realize it. You don't realize that there might be an easier way or a better way to do it, a more efficient way, because it's so complicated. That's something that, it's a big topic to go into. Maybe I shouldn't. It's just his tangent. Shouldn't go into that. There are stories out there of like, let's do it in assembly because that's more efficient. And then it turns out that it's way less efficient because you've totally lost control of how it's working because it's too much to write in assembly. So when you have a higher level language, this is a relative term, right? A language that is higher than assembly. In the higher level language, in theory, it's less efficient because it goes through a compiler and the compiler can't really understand everything you're trying to do. And it didn't get that, there's this optimization and you could have done this. And the compiler couldn't see that. Or maybe it's it's doing garbage collection for you. But in the end, if you can't understand how it's working, and maybe you don't even know if you understand how it's working, you think you understand it, but you don't know if it's sufficient or not. Okay, so. The real problem is that programmers have spent far too much time worrying about efficiency in the wrong places and at the wrong times. Premature optimization is the root of all evil, or at least most of it, in programming. There's his famous quote. One rather curious thing I've noticed about aesthetic satisfaction is that our pleasure is significantly enhanced when we accomplish something with limited tools. For example, the program of which I personally am most pleased and proud is a compiler I wrote for a primitive mini-computer, which had only 4,096 words of memory, 16 bits per word. It makes a person feel like a real virtuoso to achieve something under such severe restriction. So people talk about this a lot. It's commonly known now that constraints help creativity. And the creativity and pleasure in what you're doing, the artistry, those go together. A similar phenomenon occurs in many other contexts. For example, people often seem to fall in love with their Volkswagens, but rarely with their Lincoln Continentals, which presumably run better. When I learned programming, it was a popular pastime to do as much as possible with programs that fit on only a single punched card. I suppose it's this same phenomenon that makes APL enthusiasts relish their one-liners. When we teach programming nowadays, it is a curious fact that we rarely capture the heart of a student for computer science until they have taken a course which allows hands-on experience with a mini-computer. The use of our large-scale machines with their fancy operating systems and languages doesn't really seem to engender any love for programming, at least not at first. So there are always games and things we play, like code golfing, right? How short can I make this program? It seems like it's not a useful pursuit, right? Because your program isn't getting clearer by like shaving off characters here and there like you do in code golfing, or finding some esoteric syntax that'll let you write something in half the characters. Certainly it's not more readable. But I think it is useful. It's play, it's exploration, it's finding the pleasure and the corners of the language and relishing the artistry of this tight constraint. And we see that a lot. We see like these programming competitions where it's like, what can you do in 1K of JavaScript? Stuff like that. And some people do some really impressive stuff with just 1K. It's pretty cool. And then there's like the obfuscated C competition. It's like, how bad can you make your code? Like, why are these fun? Why? No one wants to write code that's unreadable, but yet it's fun to do it. And he's saying that the fun, the enjoyment is what is a utility, is part of the aesthetic. It's part of the satisfaction. Okay. He continues. It's not obvious how to apply this principle to increase programmers' enjoyment of their work. Surely programmers would groan if their manager suddenly announced that the new machine will have only half as much memory as the old. And I don't think anybody, even the most dedicated programming artists, can be expected to welcome such a prospect, since nobody likes to lose facilities unnecessarily. This is a really curious kind of a paradox where it's more pleasurable to solve a problem under constraints. Certainly aids creativity. But then often the constraints, you don't want to live under those constraints. Maybe if it's forced on you and you have to accept it, then you can find the creativity, but you wouldn't choose it. If you had a choice, you would not do that. It reminds me of something, I produce teaching materials, video courses and stuff I write on my site. And I often get complaints, emails complaining like, oh, it took me a whole hour to figure out how to do this. Your instructions weren't exactly clear, but I did finally figure it out. And, I just wanted to let you know, like, that you cost me an hour. Sometimes they're very angry. And, well, there are studies that show that often people do better on tests after having to figure out that there were mistakes in the material. They are more annoyed, right? If you ask them, how did you feel about this material? They're like, oh man, there was some mistake. Like, I think they used a less than sign instead of a greater than sign, and it was confusing, and so I had to go look it up in other material and like really work it out by hand myself. Finally figured it out, there was a mistake, I think you should fix it. It was really annoying. But then, of course, they get it right on the test because they did all that work to correct the mistake themselves. Does that mean you should insert mistakes? I don't know if there's good research showing that you should randomly insert mistakes into your textbooks. But it seems to be the case that building in a little bit or allowing the mistakes, right? Like, don't fix them, because it seems like people actually, they get really frustrated by the inconsistencies, or something seems wrong and they want to find out what it is. And I don't know how to resolve that. I don't want people to be frustrated. I don't want people yelling at me about some unclear thing I had in there. But I also feel like that person is never going to forget that lesson. Whereas if I gave them the right answer, they might have just copy pasted it. Like, let's say it's a command to put into the terminal. They would just copy paste it and like not learn anything about it. People don't really know. They don't really have a good sense of their own learning process. Right? So they don't realize like that process they went through was actually, anyway, I'm just complaining about this. It's a similar paradox, right? Like you would not want to work on a machine with half the memory. There's all these deadlines and you're already under pressure to get stuff right, and like if you have to deal with another constraint of like half the memory that you're used to, what kinds of bugs is that going to cause? And but at the same time, there's stuff like chaos engineering, right? Chaos monkey, which randomly kills processes on a Unix machine, just like boom, dead, kill it, kill -9, terminate, and your service just goes out. How do all the other services react? What happened? Can it adapt? Can it deal with it? And it turns out that if you have a system, no one would want this on a real system, right? But it actually makes your system more resilient, that it can adapt and handle these failures gracefully. It's another constraint on your system that you wouldn't choose, right? Like if you're programming for, like, let's say you're programming mobile phone apps, maybe it's better to have a really old phone, because then you're going to make sure it's fast and smooth on that phone. And then when the new phones come out, it's going to be super snappy. If you have the latest phone and you program for that, like only people with the latest phone will have that same experience. So maybe there is something to this. And there's all sorts of other ways that we kind of put constraints on ourselves. Some style guides say like no more than 5 lines in a function or method, no more than 3 arguments. And sometimes you want a 4th argument. Like it would be so easy if I just had this 4th argument. Like you wouldn't choose it in the moment. And often you would groan when someone imposes it on you. But it's for your own good, right? It helps you. Okay. It's a weird paradox. In recent years, the most important things we have been learning about programming seem to have originated with people who did not have access to very large computers. The moral of this story, it seems to me, is that we should make use of the idea of limited resources in our own education. We can all benefit by doing occasional toy programs when artificial restrictions are set up so that we are forced to push our abilities to the limit. We shouldn't live in the lap of luxury all the time since that tends to make us lethargic. The art of tackling mini problems with all our energy will sharpen our talents for the real problems, and the experience will help us to get more pleasure from our accomplishments on less restricted equipment. So this thing he says at the beginning, I don't know if this is true, but let's take it as a fact. He states it. In recent years, the most important things we've been learning about programming seem to have originated with people who did not have access to very large computers. He doesn't mention what he's referring to, what these most important things recently and where the people originated or why they had access to small computers. And this was in the 70s. It's probably lost what he was referring to. But it's interesting to think about that. I know that, I don't understand much about soccer, but I know that there's a kind of odd phenomenon where richer countries, they have like much bigger training budgets and better equipment. You know, they have all the free time because they're paid, millions of dollars a year. And where do they recruit from? They often recruit from poorer countries. And why? They say that like soccer in those countries is like all they had. So a kid would have a ball and like would just play all day. And so they had fewer resources, and they thrived on playing soccer. And then when given the resources of a rich country, they now are like blossoming and amazing and unbeatable. Whereas the opposite is not true, or not the opposite. Like you take someone who was raised in that rich country, kind of, had the same opportunities and more, right? They had a soccer ball at home, but they also had a million other toys. And they grow up and they're not as good at soccer. At least not at those like little technical skills like dribbling and juggling and stuff like that. Well, I don't know if that, I think that relates. It's kind of a similar phenomenon that somehow if you like find some restricted, harder area, more constrained area, you can find something new that might apply in the bigger area, but you wouldn't have had to find it if you weren't restricted. Okay, I'm running out of steam here, so I'm going to keep going. Knuth continues, we shouldn't shy away from art for art's sake. We shouldn't feel guilty about programs that are just for fun. I once got a great kick out of writing a one-statement algol program that invoked an inner product procedure in such an unusual way that it calculated the mth prime number instead of an inner product. Some years ago, the students at Stanford were excited about finding the shortest Fortran program, which prints itself out. I don't think it was a waste of time for them to work on this, nor would Jeremy Bentham, whom I quoted earlier, deny the utility of such pastimes. Quote, on the contrary, he wrote, there is nothing the utility of which is more incontestable. To what shall the character of utility be ascribed, if not to that which is a source of pleasure? So, think he's saying, this is it seems very contrived way of writing these days. He's saying that the utility of something that is pleasurable is incontestable. Because what else is utility for than to be ultimately a source of pleasure. Interesting. But what Knuth is saying is that it's not a waste of time. It's not a waste of time to explore and play and find things that really have no other utility than pleasure. Not all programming tasks are going to be fun. Consider the trapped housewife, and sorry for this metaphor. Consider the trapped housewife who has to clean off the same table every day. There's not room for creativity or artistry in every situation. But even in such cases, there is a way to make a big improvement. It is still a pleasure to do routine jobs if we have beautiful things to work with. For example, a person will really enjoy wiping off the dining room table day after day if it is a beautifully designed table made from some fine quality hardwood. Okay, so imagine this person whose job is to, has no intellectual stimulation. I think this is what he means by trapped housewife. No intellectual stimulation. They're just at home all day and they just have to clean the house. It's hard to imagine that, but I clean the house. I have 2 kids. I clean a lot. And I'm just wiping this thing that I just wiped. I clean this table and now the kids eat on it and it needs cleaning again. It's frustrating. So I understand what he's trying to say. But here's the thing that I'm going to try to apply is that if you have beautiful things to clean, beautiful tools and a beautiful, the table is beautiful. The table is like a tool for eating dinner. So you want to take care of it because it's beautiful. You just have this innate desire to make it beautiful. If you have an ugly table, it's not so fun. It's it's not going to get much better if I clean it off. Okay, that's interesting. And so he's going to make this plea to tool makers. Please give us tools that are a pleasure to use, especially for our routine assignments. Instead of providing something we have to fight with, please give us tools that encourage us to write better programs by enhancing our pleasure when we do so. It's very hard for me to convince college freshmen that programming is beautiful when the first thing I have to tell them is how to punch / job equals so-and-so. I have to second this plea. We need to make programming more aesthetic. Not just the language, but all the tools. It's ugly. It's often very ugly. Going to the command line and let's configure this system. Oh, it looks gross. One of the best ways to keep up the spirits of a system user is to provide routines that they can interact with. We shouldn't make systems too automatic so that the action always goes on behind the scenes. We ought to give the user a chance to direct their creativity into useful channels. One thing all programmers have in common is that they enjoy working with machines. So let's keep them in the loop. Some tasks are best done by machine, while others are best done by human insight. And a properly designed system will find the right balance. That's a deep thought. That you don't want to automate everything away. You want to keep someone in the loop. Okay. So he's going to talk about tools for making profilers, like things that are more about efficiency. It is no wonder that attempts at efficiency go awry so often when a programmer is never given a breakdown of costs according to the lines of code they have written. All that we have been giving programmers is an optimizing compiler which mysteriously does something to the programs it translates, but which never explains what it does. Okay, so this is what he's talking about. The human's not in the loop anymore. Fortunately, we are now finally seeing the appearance of systems which give the user credit for some intelligence. They automatically provide instrumentation of programs and provide appropriate feedback about the real costs. These experimental systems have been a huge success because they produce measurable improvements and especially because they are fun to use. So one thing about these kinds of systems that he's talking about, they're providing instrumentation and feedback. That's something that's very important for fun, is feedback. You need to have a sense that you're making some progress. So I'll give an example. My friend invited my family and me to dinner. There was a couple and they bought a puzzle. Surprise, we didn't know. And they busted it out after dinner and we started working on it. And it was, I don't know, 1,000 pieces, maybe 500. I don't remember how big it was, but it took a good hour or two to do. And, an hour in and you're feeling kind of tired. You're still enjoying it, right? It's still fun. But I realized, man, if I don't get a piece every now and then and put it into the puzzle, I'm going to get bored really quick. I need some hit of serotonin, something. Give me some dopamine. Give me something to keep going, or I am going to lose interest. You need feedback. You need to feel like you're making progress. And if you're not, and if you're just like doing a puzzle in there, you get bored really fast. And bored sounds like, get back to work. You're just being lazy. No, I need to engage my brain in the problem. Boredom is just a sign that I'm unengaged. My brain is not working on the problem. The boredom is just that feeling that my brain doesn't care anymore. You need fun and flow. For flow, you need two things. You need fast, rich feedback, and you need to have a sense of progress. You need to know where you're going and see that you're making your way there. So our tools need to do that. And he's kind of showing with optimization, we would actually do better if we made it more fun. If we made it give it more feedback. I know fun sounds so non-technical and what? It's not about fun. We have to engineer real systems. Come on, we're humans here. You got to think about the whole system. Humans are programming this thing. You need to engage them. It needs to feel pleasurable to work on it, or they're going to shut their brains off. It's just the way it is. Fun is just another word for the hormonal flush that we get when everything's working well, when we're engaged, when we're solving problems, when we're coming up with good ideas. Okay, last part. Oh my goodness. Language designers also have an obligation to provide languages that encourage good style, since we all know that style is strongly influenced by the language in which it is expressed. Okay, I mean, these days, I feel like this is common sense, obvious. The design of the language has to encourage good style. I think that we've all agreed with that. You can't just rely on the programmer to do it. There has to be some kind of aesthetic component to the language that you can tell when it's not good style just by looking at it. and that the defaults and the idioms of the language tend toward good programs, right? Now, that's hand wavy. What does that mean? Well, there's a whole science and art to that probably has developed a lot since the 70s when this was written. Okay, well, that was Don Knuth. We're up to 1974. How many of these have I done? 10? There's still more to go. They're still giving out these awards, so I don't know if I'll catch up. No, I'm definitely doing them faster than one a year, so I'll get there eventually. So please subscribe if you like this. I'm going through all of the Turing Award winners. I'm doing them in order, but I think I've done a couple out of order before I really started. But you can just find those. I'll just skip them when I get to them. Thank you for listening. My name is Eric Normand. This has been my podcast. And as always, rock on.